Okay, testing, testing, 1, 2. Testing. Okay, testing, testing. Hello. Let's get some music going, yeah? It's a little bit compressed. Let's try this. Okay, chat. Can you figure out what game this is from? It might be tricky. Alright, chat. Any guesses on what this song is? Okay, so no guesses. That was the Black Knight 2000 pinball machine. If it sounded a little bit tinny and compressed, that's because the audio hardware on those old pinball cabinets did not tend to be particularly advanced. However, in the case of the Black Knight 2000 machine, I think they did a really fantastic job. It certainly feels very nostalgic when you listen to it. Kind of reminds me of the Sega Genesis audio hardware. Okay, chat, let's move on. And let's try another song. Okay, this one might surprise you. Let me know if you can figure out what this game is. Okay, chat. What game do you think this is from? Take a guess. What does it sound like? What kind of instruments and environmental/ambient noises do you hear? Okay, a little bit islandy, sure. Yep. Ooh, sounds like a jungle theme. Ah, there we are. Chat, do you know any jungle-themed games? This is not Donkey Kong. It is the A Bug's Life game for PlayStation. This game has a really fantastic soundtrack, and the game itself, even though it's very short, is fantastic. Very, very fun kind of puzzle, platforming adventure game. It was made by Traveler's Tales, who made went on to make the Lego games. And they're still making those Lego games. They did a really great job. Okay, chat, what do you think about this one? What is this song from? What does it sound like? What genre? Nope, not racing, but close. Close. I feel it's from an action game. You are correct, but which one? This is from an action game called Beautiful Joe 2. It's the first stage, and it is set in the prehistoric past. So maybe that explains why you hear dinosaurs in the background and a little bit of jungle-y elements to it. Okay, let's try another tune here. What can we find? Let's for once let's do a song that I think everyone is going to know right away. Let me see if I can find it.
Choose your destiny. Flawless victory. Choose your destiny. Flawless victory. Fight! Excellent, Cyrax, Sector, Smoke, Motaro, Jade, Kitana, Scorpion, Sub-Zero, Soma, Jax, Marina, Johnny Cage, Raiden, Kung Lao, Reptile, Kabal, Liu Kang, Sindel, Ermac, Shiva, Lee, Cyborg, Shao Kahn.
Okay, ladies and gentlemen. Yes, again, for once we chose a tune that just about everyone probably has heard before, whether it's in a club or whether it is at a band at a football game playing it, or whether you've actually just played the game. The series sells extremely well. Mortal Kombat, always a pretty good time. Excellent. So let's go ahead and get started. I'm looking at the number of watchers we currently have, the audience we have, and it's way down. It's about probably about 66% of what it normally is. And I think maybe a few too many people worked a little bit late on the P1 milestone assignment. I'm there with you. I can appreciate that. I think I was up finishing this lecture at like 2:30 a.m. or something. It's no fun. However, I encourage you, if you happen to be watching this or have a friend who's, the career fair grind is very real. Yeah, so the timing is just very hard right now. At any rate, be sure to get some sleep, take care of yourself. These lectures are recorded. Ironically, though, today's lecture is all about some software engineering design patterns and tips for P1. It is a very engineering-heavy lecture, which is hopefully going to help you move faster through your Project 1 tasks. So we'll be talking about that. Oh, I was up till 9 a.m.? Ooh! Did you? So the question, Alberona, is did you sleep at 9 a.m. and then wake up like an hour or two later? That's the question that I want to know. Anyway, so let's go ahead and keep going. So I've got some inspiration and energy for you today if you're feeling a little bit tired. So let's take a look at that. This might be the most Michigan game I've ever seen in my life. It's a darn shame it wasn't made in Michigan. It makes me very sad. Get the full screen going here. So you've got your deer friend here. You play as a deer simulator in a way. You find these nice little attachments, and I think it's very on point. I wouldn't be surprised if this game were set in Michigan, even if in fact it was not made in Michigan. So anyway, we need to have more game dev happening in this state. We are working on it, and we're getting good progress, but we're not quite at that level yet. Anyway, let me shrink my my view here so I'm not taking up your entire screen. All right. So I want to show you some more additional things. This is an example of a beautiful example of using several graphical techniques and rendering techniques to create a really cool portal effect that's very convincing. So let's take a look here. We'll be teaching you a few of the techniques you need to do something like this a little bit later in the course. Let me see if I can get that full screen going. Here we go. Let's go ahead and watch here. We got a platformer game. Oh, come on, come on. Buffering. Come on, let's go. Play. Please. There we go. Okay, so you open up a portal. You collect this item, open up a portal. Look at that. Woof. Whoosh. Right? Look at that. And you run around and you can see through it to the other side. Look at that. We'll see it again. Whoa, right? This tear appears in space, and it looks just fantastic. Oh, wait a second. Is the tournament at 11 a.m.? It should be at. Well, hold on a second. It should be at 11:30. If it's at 11 a.m., then a bunch of people are going to be frustrated right now. Well, it's past 11:30 anyway, but I'll need to open it up for a little bit more time if. Hold on a second. Let me look here really quickly. I apologize, chat. I need to make sure no one got cheated out of their last 30 minutes of turn-in time. That would be particularly cruel. No, 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 no. It's due on the 14th at 11:30. Who just trolled me? I think it was open till 11:30. I just got trolled by someone, chat. So there you go. Anyway, look at this beautiful graphical effect. There's several things going on here. One, you have an entirely different scene, it looks like, being rendered in the background. You can actually do this with a second camera that you don't show immediately. In Unity, while it might be atypical for indie games and for smaller games, student games, you can actually have multiple cameras rendering different scenes, and you can choose not to display the results from one. Or you can use what we call a mask. A mask is a graphical tool that essentially helps us decide what to show from a certain scene. If you've worked in Photoshop or Illustrator, you might be used to that concept already. There's also this distortion that's happening. You see this? There's actual warping that happens on the screen around where the portal occurs. And this is probably using a screen shader technique, which we'll actually show you how to do later. That is essentially telling the game to render certain pixels at a place where they would not normally be rendered. So we take the pixels and we kind of squish them up a little bit. We displace them and it creates this really juicy effect. Boosh, right? And then the actual shape of the mask that tells Unity to render certain pixels from a certain camera, but other pixels from another camera. The shape of that mask is actually this animation, this animating smoke cloud. So you add all these things together with some beautiful sound, and you get this really just enchanting effect for a portal. So anyway, we'll be teaching you how to do some of those things a little bit later on in the course. Here's something that's much easier for you to do, much sooner, and I'll bring this up during Project 2 as well. But parallax, it's a beautiful technique that allows you to take a game that is 2D and it makes the game feel like it has this 3D depth to it. So watch what happens when we move. This spaceship that's going through outer space, that's going to move, and it's going to feel really deep. Just keep your eyes on that spaceship. Come on. Hey. Render. There you go. Look at that. You can't tell when you're still, but whenever you move, it feels like there's this deep galaxy full of just amazing things to find in the background, right? Look at that. Absolutely beautiful. And the idea is if you ever look out a car window as you're driving, you'll notice that things that are very close by, like the road and the nearby trees, move by very quickly. However, if you focus on the distance, mountains in the distance, a hill, a building way out in the distance, you'll notice that it barely moves. If you look at the clouds, you'll notice they barely move, right? So it's this visual phenomena where things that are very close to you appear to move much faster when you move. Things that are further away appear to not be moving at all. And if you simulate this in your game, in your 2D game, you can create this incredible feeling of depth and realism. And it's also extremely easy to do. So anyway, that's something I will remind you of if you make a 2D game on your P2 or P3. Even on your custom level, if you really want to go above and beyond, your custom dungeon or Metroid region for P1 could have something like that in it. Be very impressive. So thus far, we've focused in this course almost entirely on engineering, in how to implement things better, composition, new design patterns, stuff like that. We'll continue that today. However, the reason we're doing that is to help you get up to speed quickly with your tasks on P1, right? So that you can get into Unity and quickly start knocking out interesting features. Now that you're starting to get a little bit more of a handle on how to create things, we will start to focus on how do you create something that is fun to play, right? So what principles of design and game design can we start using to make sure our games are going to be enjoyable, so that we can create new mechanics that are going to feel very interesting and deep and expressive, while not being too complicated or confusing for players to get into. So on Wednesday, we're going to start talking more and more about design, and then I believe next Wednesday is when we will start your P1 Gold, and that is when you will be doing your first elements of design that is purely your own, okay? Purely original, and so that's going to be very exciting. I hope you look forward to it. It's a very fun part of the class. Are there any questions? Now let's do 11, okay, that I personally turned into 11. So it pulls a Star Fox, faking the perspective projection POG. It is very exciting indeed. So we already showed you the fun Project 1 bugs last lecture. If you want to see those again, go ahead and check out the recording of last time on YouTube or on Twitch. If you want to see me dancing to music, you can find that at the very beginning of this lecture. if you arrive early to lecture, you generally get a little bit of a treat for doing so. Let's see here. Assignment released. Congratulations on finishing your P1 milestone. I encourage you to take a break. Take a one-day break, but that's all, okay? Don't think about games today outside of this lecture, and consider not working on your P1 Alpha. Take a break, okay? Get some of your mental energy back. P1 Alpha is a very tough assignment. You have a ton of tasks. Essentially, if you look at your spreadsheets of tasks, right? Your spreadsheet of tasks. Essentially, you need to have just about everything in there, right? Look at the milestone column. You'll see that you need to have everything that is P1 milestone or marked for P1 Alpha now, which is essentially the rest of the tasks in that sheet. Remember, this is very important. You don't need to have a perfect implementation. You will not be marked down for bugs on P1 milestone or P1 Alpha. You will not be marked down for bugs or non-authentic elements, so long as it is there. And so long as if it's incredibly buggy, like it literally doesn't work, or it's extremely low effort, we'll consider it missing. But if it's buggy, a bit, fairly buggy, it's not a huge deal, okay? Just get everything into the game for P1 Alpha, okay? And then we'll polish it up during our final 5-day P1 Gold stretch. All right. Everyone needs a break. Don't forget to stretch and hydrate, though. Absolutely. Be sure to hydrate and take care of yourself. Make sure you're eating all your meals, okay? Okay, P1 Project Management, you're only responsible for... That is not the case this semester. That was for last semester, so I'm going to get rid of this, actually. You are responsible for your P1 milestone tasks because we got you all your projects on time. You're going to want to start thinking about your custom level and custom mechanic, right? So think back to really successful examples from the past, right? The Zelda motorbike, the Zelda slow-mo, the Metroid dashing morph ball mechanic, right? Mechanics that, one, are very impactful, right? They change the way you play the game, and they have a level built around them that really makes those mechanics super important and necessary. And two, they also fit in reasonably well to the universe and the other gameplay mechanics that have been set up. Even the motorbike, while thematically it might be a little bit strange and surprising, within the game world it really works well with the dungeons, right? The fact that it helps you jump gaps, it makes it extremely valuable. And the fact that it lets you take down enemies, small enemies, it really connects with the other parts of the game. It doesn't feel like a one-off mechanic that's just isolated. It mixes in well mechanically, even if not thematically, okay? Okay, what I want to do is I want to show you, now a few times this semester, I've told you, well, you want to make components that are really reusable. You want to make a generic component, right, that can work in a lot of different contexts and on a lot of different game objects, right? Last lecture, we had a big talk on composition and how it's really powerful for code reuse, right? If you have one component and you reuse it everywhere, then you can fix, if you need to fix a bug, you only have to fix it in that one component. And it's very unlikely that you'll forget to fix it in other places because there are no other places, right? Fix it in one place, you get the benefits everywhere. So that's the dry principle. Don't repeat yourself. You want one source of truth for as many things as you can get. You avoid copy-paste bugs that way. Anyway, I keep saying that you should create a reusable component, but what does that actually mean in practice? Well, I want to show you, okay? So I want to show you, I'm going to show you right here. I got this little project. And if you look at this project, it's a rollerball, okay? It is a different rollerball with a different camera and different controls. This was actually made for a class, the UARTS 150 class that I teach. And it uses a different way to script components, visual scripting language it uses. Anyway, here's the game, and we can collect stuff and we can jump around. I really like the camera. You know what? I might introduce this kind of camera into the 494 rollerball project or assignment because I like how this camera follows you around and lets you get a different perspective on things. It's not just the stiff and fixed overhead camera. Anyway, that's not the point of this talk. That's a tangent. What I want to do is I've got collectibles in my game, but I want to introduce a few mechanics in the next 5 minutes. I want to introduce the concept of player health. Okay? So player health. I want to introduce the concept of enemies that damage you. And I want to introduce a third concept, but I'm not going to tell you what it is quite yet. All right? I'm going to leave that for a surprise because it's going to be really awesome how we implement it. Okay? So currently, if we look around in the scene, we can see the camera, we can see the player ball that falls. What we want to do is we want to introduce an enemy. So let's go ahead and create some game objects, okay? Let's create a cube here. This cube is going to be our enemy. So we're going to bring it down a little bit and we'll bring it up. One cool thing you might not have noticed is you can drag stuff around smoothly, right? But if you want it to like clamp to the grid, you can hold control or I think hold command and it does this amazing clamp. That makes it really nice to line stuff up and make it look very planned out. Okay, so here's our enemy. All right, it's a box. So we're gonna name it that. So here we go. Stay organized a little bit. And we have also got our player here. And our player, we want our player to have a health. The concept of health. Our player should have it. So here's what we'll do. We're gonna create a new component. We're gonna call this has health. Okay. Remember, if you're doing composition right, generally your components will start to sound like adjectives. So has health, right? It is a descriptive title. If you have this component, you have a health. So we'll go ahead and create that. Come on, Unity. It's refreshing here. Let's go. Let's go. Unity's gotten kind of slow these days. I'm feeling a little bit sad about it. We'll open up this has health component. And it's going to be an extremely simple component. You'll see that all the components we make in this next 5 minutes are going to be extremely simple and short, okay? But we're going to have a few of them, and together, they'll work together to be very impactful. Okay, so let's go. All right, so the first thing we're going to do is we're going to get rid of all this stuff, okay? We want the simplest component possible. All this has health component is going to be is it's just going to store a public float variable for us. We're going to call it current HP, okay? We want to set that initially to 0. That seems like a good starting point for most game objects, and then that's it. All right, we're good. That's it. So we have our health component, and it is finished. We're going to look at the inspector here, and hopefully Unity will update us and give us a health. Current health is 100 property. Come on, Unity, let's go. It wasn't this slow in the prep. There we go, right there, bingo. Okay, so what we want to do now is we want to give our enemy over here the ability to deliver damage, okay? And as far as damaging us, what's going to happen is we touch the enemy and our health variable right here goes down, okay? So what we want to do is we want to say, you know what? We could create an enemy component, right, chat? Yeah, let's create an enemy component. You know, or we could be specific and say, okay, this is the cube enemy component. But you know what? I don't want to do that. Because if we create an enemy component, then, you know, we kind of lose some ability to customize. That's not very granular, is it? If we think about what an enemy does, right? An enemy does damage when it touches us. So let's do this instead. Okay, we'll make a more generic component. Let's do it. Call it damaging by touch. Okay, an adjective. Okay, the enemy is damaging by touch. You know, adjective, right? It describes what this game object can do. Instead of saying it's an enemy, right? An enemy component, we're going to say damaging by touch because imagine this, an enemy that doesn't damage you if you touch it. We want to keep that possibility alive because maybe in the future we want that kind of enemy. It's like a ghost enemy. It doesn't damage you when it touches you. It has to shoot lasers or something. Okay, so we'll create damaging by touch component. So let's go here. I think that's some dialogue runner stuff back there. Okay, so I think Visual Studio messed up for us. So we're gonna wait for Unity to add our component here. It's thinking. And there we go. Damaging by touch. Okay. Now the first thing we're gonna do is we're gonna get rid of all this stuff. We want another very simple component. All right. So damaging by touch. What it's gonna do is it's gonna get a trigger event here on trigger enter. And the first thing it's going to do is it has to grab the has health component. Has health, other health. Okay, we'll grab a reference to the other component, the other game object that just touched us. We'll grab its has health component. Now consider this, everyone. If we could touch something that doesn't have a has health component, what should we do if this is the case? Well, if we try and get the other health, the has health component, but it's null, then we need to bail out, okay? Because we can't hurt someone who doesn't have a has health component. So if other health is equal to null, what we're going to do is we're just going to return, okay? On The Sims, we called this early return and early out, okay? If the conditions aren't right for us to act, we need to bail from this logic. This is a thing I really love because if your entire team is using this pattern, this approach, if you ever wonder what the conditions are for doing the logic in this function, you just look at the beginning and you see all the places where the code bails. So anyway, so if the other player does not have a has health component, then we bail, okay? However, anywhere below this point, we know that they do have health, okay? So what we'll do is we'll say, okay, we're going to take this other health, we're going to say current HP minus equals 10, all right? And we'll go ahead and test it real quick because we always want to test our little changes, however small they might be. And this will actually error out because we can't get an on-trigger enter event on this enemy game object unless it has a rigid body. So we got to add a rigid body. But you know what? Here's a tip for you. This damaging by touch component should not be on any game object that doesn't have a rigid body. So here's what we'll do. We're going to tell this component that if it is ever on a game object, there should be another component. So we'll do require component of type rigid body, okay? Right here, this says, you know what? If I am attached to a game object, you should automatically put a rigid body on it, okay? And so we're going to compile this component, and then what will happen? What will happen? Hey, yeah, it didn't do anything. Let me remove this real quick. Damaging by component, damaging by touch, boom, we add it on. And, oh, there it goes. It added the rigid body for us automatically, okay? Let's do another thing. We can add multiple damaging by touch components, right? We can put multiple on, but that doesn't actually make sense to have multiple. Here, let me get rid of my my thing here. It doesn't actually make sense to have multiple of these components, right? You only ever will need one. So let's go in here and let's add another little attribute. Disallow multiple component, okay? So what this does right here is it says, you know what? If the game object already has one damaging by touch, don't let the user or developer put another one on, okay? So we're making this component hardier and hardier. The component is accounting for more things that could go wrong. If there's no rigid body on the game object, it adds one automatically. If the user tries to put on multiple, well, that wouldn't make sense, so it blocks us. It says can't add damaging by touch to enemy because the damaging by touch is already added on the game object component. So there we go. We'll turn off the gravity here, and then we should be able to hopefully run into our object. So let's look at our player. Watch the health, everyone, as our player runs into the thing here. Runs into this object. So here we go. We're going to look at the player. There we go. We got 100 health. And boop. There we go. All right. Actually, that did nothing at all. So let's take a look here. Oh, here's the issue. The enemy does not have a trigger. Its collider is a normal collider, so the on-trigger enter won't execute. Now let's try it again. This is why you need to do tiny testing all the time. It's much easier to know what has changed and what might have gone wrong if you only have a little bit that has changed since your last playtest. Okay? Boom. There we go. We hit it and we took 10% damage, all right? Fantastic. So what I want to do is I want to clean that up a little bit. Personally, I don't like just going in and immediately just grabbing someone else's variable. So let's do this. Public void alter HP. And what this function will do is it will take a float called delta, and it will take our current HP and it will change it by the delta. So now instead of grabbing the current HP itself, what we can do is we can do alter HP, and we want to alter it by -10. okay? I want to do something else, though. I want to actually make this a little bit more generic, so we'll go ahead and make this a public variable. So instead of -10, what we'll do is we'll go, okay, change in health, okay? And we'll set that to -10. And we'll put this in here, and there you go, okay? I want to do something else. I want to not only alter health when I touch this, damaging by touch component, but I also want to apply some knockback, okay? And how we'll do that is we're going to calculate first we'll define a knockback power, okay? And let's set that equal to 10. We'll go ahead and grab, okay, what direction do we want to send our player in? So let's go knockback direction. That's going to be the vector that goes between, from us, the enemy, to our player. We can get that by doing other.transform.position minus transform.position. This right here is the vector, the 3D vector that points from where we are, right, to where our colliding object is, where the player is. We're going to normalize that vector because it is a direction. And then we need to apply it. However, we can only apply it if the other object has a rigid body. So we'll do this. We're going to get other RB. We're going to grab the other object's rigid body by doing this. Get component. Then we'll say, you know what? We'll only do this knockback if the other rigid body is not equal to null. Okay? Otherwise, we'll just apply damage and we won't do any knockback because the other object doesn't have a rigid body, which means we can't do it, okay? Now we can do RB.velocity is equal to knockback direction times knockback power, okay? So boom, there we go. Let's see if it happens. We've written a good bit of code right there, so we need to play test right away. Always playtest. You should be making a small change playtest. Make a small change playtest, okay? It'll be much faster if you develop this way. So let's go ahead and take a look here and, oof, ouch. You could feel that, couldn't you? My goodness. Let's check our health to make sure it went down to 90. There we go. Look at that. It's 90 now. Okay, here we go. Ugh, ouch. Oh my gosh. It's tough. Anyway. So there we go. We got knockback going on. We'll quickly make this a little bit more generic as a component by just taking this 10 and we will just take it out here. We'll make it a public variable here. So now we can adjust it if we want to. However, chat, I have something that might blow your mind a little bit, okay? We now have the ability to change health when you touch something. And I want you to ask yourself, chat, does this sound like it could be used for anything else? Our current component is called damaging by touch. But I want to change this because this is too specific. We can make it more generic and reusable. We're going to use this component to implement a health pickup, okay? Because instead of this being -10 if you touch it, if we make this +10, suddenly we can do a health pickup. So let's do this. We're going to create a new component over here, and we're going to call it a health pickup. You know what? We're going to actually make this a pill instead. Okay, so it's a little bit visually different from our enemy. Make this a capsule. So there we go. Here's our little pill that's going to be healthy for us. What we need to do is we need to give it a rigid body. We'll add the damaging on touch component. However, this component's name no longer makes sense. So let's find the damaging on touch component and we'll change its name. We're going to change it to change health on touch, okay? And we have to go back into it and we'll change its name here, change health on touch, okay? We'll let Unity recompile. We'll recompile. Let's go, Unity. I feel like most of the time here is just Unity compiling stuff. Anyway, we'll go to this capsule. It now has change health on touch. We'll set it to 10, okay? We'll set this to -10. That's good. We'll set our knockback to 0, okay? We need to change something too. When you collect a power-up, it needs to disappear, okay? So we're going to create a new bool should destroy self on touch, okay? And this is going to be false. However, if a developer or a designer sets it to true, then we need to destroy ourselves. Okay? So if we should destroy ourselves on touch, when we touch something, we will go destroy our game object, okay? We're also going to do something like this, okay? We'll only do knockback at all if knockback is not equal to 0, okay? If knockback is 0, we just won't do anything. Okay, so now this component, see, it's just getting more and more general, more powerful, and we can use it in more places. So what we'll do is we'll go into our capsule here, our collectible. Should we destroy ourselves? Yes, we should. If we touch it, should destroy self? No, we shouldn't. The enemy should not be destroyed if we touch it. We'll play the game, and I actually think we're going to have a problem. Do we have a rigid body yet? I think our pill's going to fall through the floor. Maybe not. I don't think our pill has a trigger. It does not. So again, that's why we play test constantly, so we can quickly find these issues. We're going to turn off gravity, turn on the trigger. All right. Okay, so we're going to walk over here and oof. Okay, check our health. Check our health. Verify we didn't mess anything up, okay? Always verify. Okay, look at our health. It's 90. Okay, we're going to go. Let's go. Boop. Hey, look at that. And our health is back to 100. Look at that. All right. Now, this might seem like not a big deal, okay? But understand the power of this, chat. We went from implementing a very specific component. Okay, it's going to be an enemy component. Okay, it delivers damage. Okay, but then we generalized it. We generalized it to a deal damage on touch component. And imagine that could be placed on a non-enemy game object. Imagine you want to implement spikes or a fire in your game. Well, it's not an enemy, but you can just add on that deals damage on touch component, and suddenly it just works, right? And then we generalized it even more. You know what? An enemy isn't that different from a power-up, right? In that they both change your HP when you touch them. So let's take our component, make it even more general. Now, it is not a deal damage on touch. It is an alter HP on touch component, right? It's even more general. So, chat, I want you to think to yourself, what is the next step for this? Ask yourself this. In certain games like RPGs, there are certain items you can collect that don't change your health, they change your attack power, your defense, something else. So maybe we could make this even more generic and reusable by adding another property here, a string that is, statistic to change. And maybe it starts as HP, but it could be strength or attack. And then we change this component to change statistic on touch. See, we're just getting super generic. And it can be used in so many different places now, right? So anyway, if you go too far with this, you might end up with an anti-pattern, right? The God component, where it's just one component that does everything. But this is still a pretty simple component. One thing that you might consider doing, chat, is you might consider breaking out knockback. Okay? Break knockback, take knockback out of this component. Okay? And create a new component that's going to be something like, I don't know, apply or deals knockback on touch. Okay? So then what you would have is your enemy would have a change statistic on touch component, and that would be HP. And it would change by -10, right? And then the enemy game object would also have deals knockback on touch component, okay? And so you could, if you wanted to, you could then create an enemy that deals knockback but doesn't deal any damage. Or you could have like an invisible wall barrier that deals knockback to keep players out of an area, but it doesn't deal any damage. So you can see that as we generalize our components, we get more power and reusability. We can also break functionality out of components, right, to create more components that can be mixed and matched much easier. Okay, and you're reusing code all the while. You are maintaining dry, right? So a single source of truth, which means that bugs are going to be fewer, and you have more flexibility too, because you have a lot of components that are very powerful and can work in a variety of situations. Notice this, chat. This component is reusable in many places, in part because it actually checks it checks its environment. It makes sure that the thing I'm touching has a rigid body. It makes sure that the thing I'm touching has health. Okay. So anyway, hardy components are always checking, okay, what game object am I on? Do I have the components I need, right? Yeah, good hardy generic components will also enforce that, okay, if I'm on this game object, it must have a rigid body, and if it doesn't, I'm going to add it, okay? So anyway, keep this in mind. So question. What are the general feelings toward giving a component like this a unity event to give more specific functionality for an object on collision? Or is that something that should be avoided like a God component? I think I'll be talking about basic events a little bit later in the lecture, so I'll try and answer that a little bit later, okay? But event systems are very powerful. I don't personally use Unity Event. I use a custom event system that was created by my company. I'll show it to you a little bit later, actually. It's based on PubSub. But anyway, that is what I wanted to show you there, okay? You can download something very similar to this. It doesn't use the same project. It's a different rollerball, but it uses the same code. You can download this here if you want to after the lecture, okay? Okay, and writing generic hardy components that aren't fragile, that work everywhere. There's some tips there, okay? I want to give you another look of what commercial grade component reuse can look like, okay? So I'm going to show you a tower defense game that my company is currently making, Arbor Interactive. And by my company, I essentially mean just me. I'm the engineer on it, the only one. So code reuse, okay? In this game, we have a tower game object. You see this? Let me go ahead and make this bigger, actually. And I'll make my little window smaller here. There we go. Okay. So right here in this game, we have a tower game object. You can see it right there. It's a clam, because this is a beach-themed tower defense game. Okay. We got crab enemy units coming in. We got a player unit right there. And we've got our little tower game object. Okay. It's a clam. We then have unit game objects, right? So little characters that stand around. You can order them around. They can fight stuff. They can collect stuff. And then we also have map units. Okay, so this is a unit that is on the map. So this is the stage select that we're working on. And you can click on nodes, and they'll run around to those nodes, and then you enter a stage. Okay? And so the cool thing about this is that we have these different game objects here. And they're doing different things, right? The tower just stands there and shoots at enemies. You can see it spitting at the crabs here. You have the units that actually can walk around and fight stuff and be ordered around. And then you have the map unit, which can actually be ordered around on the map. So the question is, what components can you reuse across all of these? And as it turns around, quite a few, okay? So here is the inspector when you are looking at the tower, okay? We have a has data component, an is tower component, has team, has desired position, has default team, has vision, so it can see stuff, has brain, so it can think about what to do. It is selectable, so you can hover over it with your cursor and click it if you want to. The game object, the unit game object, has all these components. Unit navigation, has velocity, has data, has team, okay? Can punch, has vision, so it can see stuff, selectable, right? And then the map unit game object has all of these components, has velocity, has desired position, has data, right? And what you notice if you look at these is that there are a lot of components. They tend to do fairly specific things, and these components are reused across all these different game objects. For instance, has data is a component that is reused on all three of these. The reason is because the has data component stores statistics. So it stores HP, it stores attack power, it stores defense, it stores speed, it stores vision distance, okay? So you can just use this anywhere if you have an object that can have different datums, we call it. Anyway, all of these two have a team associated with it, right? So this clam tower is on a team. It's on the player's team. This unit has a team. It's on the player team. So we can use that component across those two different game objects. What about has desired position? All three of these have some place that they are thinking about, okay? So the tower has a desired position. That desired position is the nearest enemy, right? That's the place it shoots to. This unit in the middle has a desired position. It's the place that it wants to run to. This unit on the map has a desired position. It is the node that has been clicked, okay? Selectable, right? All three, not this one, but these two can be selected, right? Because, they might be different game objects, but you can still the player should be able to hover over them and be able to click on them and get some different affordances that they can do, some different options that they can do with this unit, okay? These two have a vision, right? What's really cool is that if you want to blind a tower or blind a unit, what you do is you just go in and you just toggle off the vision. And what this does is suddenly all the other components, right, can't figure out, they can't see, okay? Because the has vision component is what allows a unit to see. So it's really cool, actually. Because it's so granular, it's super easy to implement a blindness debuff in this game. To where if you get hit by this blindness debuff, the only thing it actually does from an implementation perspective is it just turns off your vision component for a few seconds and then turns it back on. You're blinded for a few seconds. It's really, really great. Anyway, what was the one that just appeared? Has vision, right? Very nice thing to have. Anyway, this is just a kind of a commercial example of what units and characters and towers can look like in the inspector when you have kind of a more deluxe game, okay? By the end of your P3, you might get up to the point where you have game objects with this many different components and this many different shared components between them. It's a very, very nice situation to be in. For instance, a vision. We have an algorithm that basically allows us to detect whether someone's vision is cut off, right? So if there's a solid block between a player and an enemy, then they won't be able to see the enemy. Well, that vision algorithm is used in all of our different game objects because they all have this component. If we make that vision algorithm 20% more efficient, 20% faster, we instantly get the win, boom, the performance win in all these different game objects because they're all using that vision technology in that one component, right? So we get the nice benefits of dry that way. Anyway, that's just a quick and fun little example. Let's keep going, okay? What I want to go over now is I want to go over something that's a little bit specific to your P1. And this applies to both Metroid and Zelda, okay? This is something that you should be thinking about when it comes to implementing items, implementing enemies, implementing other stuff as well, okay? Let's load our presentation here. Come on, let's go. Okay, bring it up. Okay, so P1 architecture. Let's say that you need to implement, let's say you're doing Zelda, and you need to, but this also applies to Metroid. Let's say you're doing Zelda, and you need to implement movement for these three different objects, okay? These are three very different game objects, but how different exactly? Is there anything we can reuse? Well, your objective is to get these moving, all right? And the question that you should ask yourself is, okay, these game objects are different, but they're also similar in a sense, right? Should we create one component to move all three of these, or should we create three? All right? And you can weigh the advantages and disadvantages. So one advantage is, hey, one component, we get dry, right? Fixing a bug in that component fixes it everywhere throughout the entire code base because it's only one component that all the different objects are using. One really good thing, too, is that it's very easy to reference one component, okay? It scales really well. This is how you do it. If you have a game object and you want to turn off its motion, because you hit them or something, or you need to pause the game. You have a pause menu you need to implement. Well, it's super easy. All three of these game objects have the same movement component, okay? and you can just turn it off. You can use this code, and no matter what game object you use this on, GameObject.getComponentMovement.enabled equals false, that will just work, okay? So some disadvantages, though, is that this is kind of hard to implement, right? Because you have these three components, and they move in slightly different ways, okay? The alternative is to use three different components, okay? Now, the good part about this is it's relatively straightforward. You just, hey, okay, you do the Stalfos movement, okay. You do the gel movement, okay. You move on to another component, you do the Goria movement, okay? The disadvantage is that you lose dry, right? So if you have a bug in your movement of your Stalfos and you fix it there, the bug might still be present in your gel or your Goria, and you might forget to fix it, and then you'll get dinged when P1 Gold comes around, okay? And another issue is that you cannot reference that movement object generically in a really easy way, all right? Here's what we mean by this, okay? When you only have one component that's a little bit more flexible and powerful, you can just do this, okay? Hey, I collided with the enemy, turn the enemy's movement off. Maybe this is the code for your sword in the game, right? The sword is something that should, if the enemy detects that it has touched the sword, it turns off its motion, okay? Here's how we might implement that if we have three different components, okay? So who did I actually bump into? You don't really know. So, okay, you have to get the Stalfos move component, or the gel move component, or the Goria move component, right? You have to write 3 lines here instead of 1. And in fact, this isn't quite the end of it, because you have to check to make sure that it has that component in the first place, okay? If all your enemies use that one movement component, you know that they're going to have that movement component. So you can just do this. However, you might have to check which one the enemy game object actually has if they're using different components, okay? Oh, okay. So if the Stalfos move component is not equal to null, that means we have it, so we do the turn it off, right? And if they have the gel movement, we turn it off. If they have the Gory movement, they turn it off, okay? This is not so great, but the bad part, the really bad part, is that this scales really poorly. Because you may have noticed that every time we create a new enemy, we need a new enemy movement component. And unfortunately, every time we have a new enemy movement component, we have to return to this code site, and we have to add a new if clause to it. Okay, every time a new movement-related component gets created, we have to add a new line here. Okay? Yes, and a really good solution for this, it's coming up, but it would be to use a base class. Okay, we'll talk about that in a sec. You want to avoid this situation. In general, chat, and this is the big takeaway, if you ever find yourself like having to return someplace, you know, hey, I created a new movement code. I created a new movement script. And, oh, wow, I have to return to these 3 different places in the code base to, like, hook it up so that it works. If you ever notice yourself doing that, something has gone wrong. You're not scaling well, okay? If you create a new component, ideally it should just work, right? You shouldn't have to go scour the code base for all the places where you need to hook it up, okay? This is an example of, okay, I created a new movement component. Now I need to return to this code to hook it up just so that it can be turned off if the enemy gets hit by something, okay? So that's bad. That's a code spell, all right? So think about this. You might want to just implement one component, and we'll talk about how to fix it here if you want to go for 3 different components. But think about this. You implement these 3, then you do it with one component, which might be possible. Not too hard, because they all have pretty similar movement. They move on the grid, right? Suddenly, you must implement the Keese, the bat enemy. Oh my gosh. Chat, do you want to implement one component that works for all 4 of these? Right? These 3 on the left, that might be doable, right? You might be able to figure out how to do that pretty quickly, because they all have fairly similar movement. However, the Keese has movement that is so weird. It flies at angles. It flies over walls. It flies for a while, and then it stops, and it rests, and then it flies again, right? No way. No way, no how, okay? You would be in a nightmare scenario if you were forced to implement one component that does all four of these, okay? So what I would recommend is and it's a hard decision to make. These are the kind of things you need to design when you're thinking about your code base, right? Talk with your partner, figure this out. I would recommend you say, okay, we're going to do these three with one component. It's going to be called the grid movement component. And then we're going to do this one with a component called the flying motion component, okay? So 2 components is a really nice mix, okay? We get the easiness of implementing, of being able to implement kind of specialized behavior for these 2 different types of movement, but we also get some amount of dry, right? So if we fix anything in the grid movement component, the fix goes to all 3 of these characters, and then we have to remember to fix it in the flight movement component, if it's even there, right? So we get this nice mix that's going to get us moving pretty quickly, all right? So let's say that you want to do some reuse. You want to you want different components, right? So you have 3 different components for movement, or enemy attacks, or something like that. Or maybe you have 2 different components, right? You've got your flight movement component, and then you've got your grid movement component, right? These are both related to movement. But you want to be able to do this, okay? This right here. You want to be able to just get the component, get the movement component. Whatever movement component it is, I want to get it and turn it off, okay? Let's say we want to do that, but we still want to have 2 different components and not just one movement component that's generic, okay? Well, what you can do is this, all right? You can do an inheritance approach, okay? We're going to create a base movement component class, okay? The other approach is called the introduce intent component, okay? So what will happen is we'll create a movement component. That movement will have it won't have anything. It doesn't need to have anything. What we'll do is we'll create 2 base classes, the humanoid grid movement component and then the flying movement component, okay? They will both derive from this base movement class, okay? Now, what you can do is you can write this code, okay? You can write this right up here, this nice 1-line code, and you can specify, I want to get the base class. And what Unity will do is it will find any child class, any derived class, and it will give it to you, okay? And then you can reference any child class very generically in that way, okay? One of the students in chat kind of predicted this would work, and it's a very, very good move, good thinking, whoever did that, okay? Yeah, and you can run this code right here. I've been blocked on the bottom left corner here, right? You can write that excellent piece of code, okay? That code will scale because as long as you are creating new movement components and as long as you derive them from the base movement component, this line will always work. You don't need to update it. You don't need to add additional lines. It just works. It scales, okay? Another option is to introduce what's called an intent component, okay? So you might do something like this, has intention. You create a component, and this serves as like the brain. This is like the desire center of your game object, okay? So you can have like a public bool, wants to move. You can have a public vector 3, where do we want to move? Desired position, okay? It's like the brain of your game object, and every living game object in your scene is going to have one, guaranteed, okay? So then what you can do is you can write components that work like this, okay? So you can write a bat movement component, and the very first thing it does is it grabs its brain, it grabs its very own brain, and it asks the brain, hey, do you want to move? If the brain doesn't exist, or if the brain says, I don't want to move, then we don't move. We just early out right there. However, if the brain does want to move, then we can go ahead and just perform that movement, okay, in the line you see down there, right? So that's another way to be able to kind of generically turn off a bunch of different child components of some sort of base class. This uses inheritance. This one does not, okay? Anyway, essentially, in every movement component, with the intent-based approach, every movement component you make, its first job would be to ask the brain if it even wants to move at all, okay? And if you wanted to turn off any movement component, you would grab the brain and tell the brain that it no longer wants to move. This would cause literally any movement component you wrote to turn off. Maybe it's not the best solution though, because suddenly every single movement component you write has to remember to have this block. Otherwise, it won't listen to the brain and it'll always move. Okay. So anyway, to disable, you just grab the brain and tell it that it no longer wants to move, and boom, all the movement turns off. All right. So anyway, these are just some things to keep in mind as you program. If you ever find yourself returning often to different parts of the code base to add like a list, like if you notice a list is forming, right? You're getting a code base that's just going, just getting longer the more you program, then you've got something that's gone wrong, okay? Keep in mind, this is really bad because you might remember that you need to add another line here. Like, okay, I create a new movement component. I need to add a new if statement here. Okay, good, right? However, your teammates might not. Okay, if your teammates don't know about this code site, they might create a movement component, not update this, and then you have a bug, okay? So part of programming in a really scalable and dev time efficient way, right? You know, part of getting rid of spaghetti is thinking about, okay, if I handed this to my partner, how could it go wrong? Okay, if my partner had to implement a new enemy or a new movement component right now, what would they not realize, right? What bugs would they probably introduce? Okay, if you think that way, you can kind of design your code and your systems in a way that kind of becomes foolproof, partner-proof. You got to partner-proof your components when you make them, okay, and your systems. Okay, we'll talk a little bit more about that in just a little bit. Today, what I want to do in the second half, we're going to spend the second half of our lecture going through a system design, okay? We are going to implement a system right in front of you that is going to be a toast system, okay? It's going to be a really nice system that is isolated, so it doesn't really impact other systems all that much in all of our other code base. It's going to be kind of self-contained, so it'll be simpler that way and less spaghetti. And it is going to be very accessible, so it'll be very easy for any other system to use this new system. And hopefully it'll be very useful. It'll introduce some concepts of callbacks. It'll introduce the singleton pattern and the observer pattern, which are two very powerful patterns that can help make your code a lot less spaghetti. And then probably in a few weeks, we'll introduce an even better pattern called pubsub that really can help you despaghettify your code base. Anyway, I'm going to be back. I'll throw some music on, and we'll be back in about 5 minutes, okay? Excellent. See you then, chat. Let's get some Kirby going. How about that? The answer would be sunshine. Okay. Yeah, Kirby as a series just has incredible music. Very consistently fantastic. Okay, so I think we're running a little bit behind, and I want to get through this. So let's go ahead and rock and roll, chat. So what I want to do is actually, you know what? Here is the dilemma that you face. Okay. So you all made Flappy Bird. You all made Flappy Bird. You released the game, and you're looking at reviews, and you discover that there's a problem. Okay. There's a big problem. Several of them, in fact. Okay. Okay, pretend this is Flappy Bird. Okay, after release, feedback comes in, okay? And people tell you, hey, I don't know the controls. You know, where's the epic story? I need some guidance on what am I supposed to do, right? When have I gotten a high score? I want to know. Is my score better than others, right? And so the design team at the studio you're working for hatches a plan, okay? We need a way to contact the user at any time during gameplay and give them any information we want, okay? And this needs to work at any moment and from any part of the code base. This has to be extremely easy for other devs to use, okay? So here's the idea. We're gonna create a toast, okay? Here's the toast. You might have seen these in Android. If you ever see a little pop-up at the bottom, that's a toast. Android has its own toast system. Spelunky, games like Spelunky have a toast system implemented too, where at any time they can just give you some text, right? It just appears at the bottom. It's beautiful, and then it goes away after a few seconds, okay? And here's an example of a rolling toast that we did for one of our games for the government. So you can you can send any message to the user, and it kind of gets into this queue so the user can see it, right? So here's the toast. We're going to create a toast system. Here's the requirements, okay? We must show a caller-supplied message to the player. So the input to our system is a message, a string, okay? It must be super easy to call from anywhere in the code base, okay? So we'll get to how that's going to be super easy in a sec. It must always be available no matter what the current game state is. So our system can never, ever go away, even if we change scenes, even if we reset the game, okay? So in other words, I'm going to show you what this will look like at the end. The system, pretend that the design team created a little video of what they want, and they send you this video. So this is what they want. You're playing Flappy Bird like normal, right? And then you go through and you get a point, and oh, you got a high score. So you get this little message that tells you congrats. Oh, you got a new high score, right? But then if you die and you play again, it doesn't tell you that message until you start getting more points, all right? And maybe the design team wants to do other stuff. Like maybe they can give you some background lore. For every point you get another piece of lore or something like that. That could be kind of interesting. Yeah, it probably wouldn't be, but anyway. Oh, that's awesome. I love how it bounced off. Anyway, that's what we want to implement, okay? A very simple system, but effective for delivering a message. Okay, so let's keep going here. We're going to do 3 phases of the development of our system, okay? We're going to mock the UI. What does the system look like when it's working? We're going to mock the system state, okay? So how does it work, right? How does it receive some input and actually go through a process? What is the input like? And then we're going to integrate these, okay, into the entire game. So when you're designing a system, it might sound simple, and it is, but it's worth keeping in mind. What you really want to think about first is what are the inputs to the system, and then what are the outputs, right? What does it consume, and then what does it do with those inputs, okay? What is the outcome at the end, the impact it has, okay? So let's say that you wanted to implement a player manager, okay? This player manager is responsible for spawning in players. It takes a player number. Do you want to spawn in player 1? Do you want to spawn in player 2? It also takes a location, because if we're going to spawn in a player, we want to know where we're spawning that in, right? So it takes these 2 things, a player number and a location, a vector 3. And then it just instantiates, it figures out what the player should look like, it figures out what level the player should be, it loads the player in at that location. Maybe it also goes further, it checks to make sure that location is valid, and if it's not valid, it tries to spawn in that player at a nearby location that is valid, right? Maybe it does that, so it's safe to use. We want our inputs to our systems to be as simple and constrained and concise as possible. You might ask yourself why. Well, we want our system to have simple inputs because simple inputs are going to probably create a simple system, all right? So if we can keep our inputs constrained, then our users our system's going to be easier to implement, but it will also be easier to use. Remember, one of our requirements was that this system should be very easy to use. So we want to keep our inputs and options as simple and as concise as possible, okay? So Toast Manager, what we're going to take in is a string, the message that our user wants to give to the player, our developer wants to give to the player, and then we're just going to make a message visible in the UI. That's it, all right? Where to begin with implementation? This could be complicated and a little bit intimidating if you view it as a whole, right? An entire Toast system. But if you break it up, you've actually implemented all of these things before, okay? Like you have implemented, putting a message to the screen. You've implemented sending messages through a function call, right? So we'll just do both of these things together. So to mock, like sending a message to the system, we'll just do debug.log, right? or to mock showing something to the user, we'll just debug.log it, okay? Anyway, to simulate stuff, we'll just use a button press. Instead of integrating everything, the system into the rest of the game, we'll just use a button press to fake it, okay? For now. So anyway, let's get started. I feel like I'm rambling a little bit. I apologize. It was kind of a late night, but I think you'll get it as we start moving. So let's take a look at this right here. We've got our Flappy Bird project. It is a kind of generic project. And let's make sure that it works the way we expect it to. Okay, we got our bird going. Wow, that's way too slow. Oh my goodness. I hope there's a variable here. Spawn rate. I don't think scroll speed. There we go. Let's do it. Let's do -4. Let's go a little bit crazy. Let's see. Chat, are you still, is the stream still okay? Okay, we're going faster now. Okay, right? It works the way we expect. Looks like the stream's doing okay. So it works the way we expect. So what we want to do is first we want to mock up some UI. Okay, so let's go ahead and get into the UI. UI is something we haven't talked a lot about in this course. But a couple things to know. UI, with a canvas, you almost always want to make the canvas and UI elements kind of scale to the size of your window when you build the game. So you'll want to go into Canvas Scaler and you'll want to actually scale with screen size. You'll want to then set kind of a reference resolution. And 1920 by 1080 is a very common like full screen monitor size. What this will do is if the size of your game window changes, that Unity will automatically adjust all of the canvas elements to kind of reflect how they would be if you just scaled down to that size. If you don't fix your canvas scaler in this way, it won't do that. And then you'll notice that your UI elements are way too big, or they're in the wrong place, or they're way too small. Anyway, a more interesting part of this, let's go ahead and create a, let's get a nice UI panel going, okay? Hey, we got a big UI panel. It's humongous, and it's covering part of the screen. We can realize this if we just change the color, right? It's covering the entire darn screen. So let's go ahead and let's shrink this a little bit. So I'm going to change its anchor, and we can move it around, right? Let's go ahead and make it a little bit smaller. Let's make it something like, I don't know, 200. No, that's too small. Let's make it like 400. 500. That's pretty good. And we can make it like 200 wide. Yeah, that's too big. Let's make it 100. Okay, cool. And just so we can see it a bit better, we'll change the color. All right, good. We can now move it around, right? One thing that you want to think about when it comes to UI, and this might be a bit confusing at first, is that UI, it wants to be anchored to something, okay? So when you say, hey, I want this piece of UI to be at x equals 15, y equals 20, Unity doesn't really know what that means, okay? Unity thinks, oh, okay, you're at x equals 14. Well, that is x equals 14. 14 to the right of where? To the right of center, okay? If you look at our anchor point right here, all of our coordinates for this UI element are relative to the center of our screen. That's really awkward for us because our UI element is going to be at the top of the screen, right? Pretty much all times. So what we want to do is we want our anchor to be at the top of the screen, okay? You can see once we change it to top, we see, wow, your UI element, our panel is negative 500 pixels below the top of the screen. So if we go ahead and make it 0, you can see that our UI element is now at the very top of our monitor. This still doesn't look quite right though. The center of our UI panel is currently exactly at the origin, right? It's right at the anchor point where we set it, right at the top of the screen. However, that's not actually what we want. We want the bottom of our panel to be at the top of the screen, right? The pivot point, right, where all of our calculations are based on, local to the panel, it's currently in the center, right? The pivot is in the center of our object. So what we'll do is we're going to put our pivot at the bottom of our object by setting y equals 0. It's not in the middle right, 0.5 of our UI object, it is now at the bottom, okay? So we set that to 0. We can now see that our pivot point is at the bottom here. And if we set it to 0, kind of set it to the origin, we can see that, okay, now our object is where it should be. It's at the anchor point. Our pivot, which is at the bottom of our object, is at the anchor point, which is at the top of our screen, okay? This might take some practice, but it's actually pretty nice once you have a little bit of experience with it. We'll put it right above the top of our screen. And what we want to do first, let's actually do this. We're going to bring it in. What we're going to do is we're going to have our own UI. We're going to have a toast system, okay? So let's create a component, toast system. Okay. So we got our toast system going on. And we'll wait for Unity to go ahead and compile for us. Okay, we got our toast system, all right? Now, with this toast system, what we want is we want it to be super easy to use, okay? We want to just, let's just get something working, okay? Let's just get any message at all. I don't care how. Let's get it displayed in that box, all right? So this box, this panel right here, let's call this the score panel. Actually, no, let's call this the toast panel. Call this a toast panel. And then we're going to need some text in there. So we'll go add some text to it. We'll call this the toast text. All right. And we'll put a little mock message in there. Hello world. It's very small right now, right? So you can see this toast text is inside of the toast panel, but it's only taking up a very small part of it. So what we'll do is we'll say, you know what? We want to anchor this toast text not to the center, but we want to anchor it to all corners of this object. Then we can kind of stretch it out like this. See, now it takes up the entire region, and we can make the font bigger so we can see it up here. And I actually want to center it as well, and we'll tell it that it should use the best fit. So it should use whatever font size works for the amount of space that it has, okay? Cool. So now what we want to do is we want to be able to set our toast message, okay? So let's do this. Let's do public void request toast. And we need to send in a message because that's the input to our system. And what we'll do is we need to put that text, this message into that text box, okay? Before we can do that, we need to actually get a reference to that text box. So let's go ahead and grab this. We're going to grab two references. We're going to grab a rect transform, toast box rect. Let's do RT. And we're going to grab a text reference to the toast text. Okay? A rect transform is essentially a transform. You might not have seen this before or might not have seen it much, but it is pretty much a transform component that is for a UI object, okay? If you look at any game object that is parented to a canvas, you'll see that it doesn't have a transform, right? Almost every game object in Unity has a transform component. However, if it is a UI object, then it will have a rect transform component instead, okay? That's just kind of a thing you need to know. Okay, so let's go ahead and fill these references because when the game starts, they are null. So we need to find this reference. So what we can do is we can go, we can either create public variables and drag them in, but I don't think I'm going to do that this time. Let's do this. So the toast system component is on the canvas. It needs to reach down to the toast panel and then to toast text, okay? So we'll write some code that does that. So toast box RT is going to be equal to transform. Oops, look at that beautiful code. And it is a early morning. Okay, so we're going to find our child game object that it has the name toast panel. We will then grab the rect transform component of that object, okay, to fill that reference. Okay, toast text will do something similar. However, since the toast text is inside of the toast the panel, what we'll do is we'll just do a find here, toast text, I think I called it, and then we'll do get component text, okay? So hopefully these references will not be null. It'll find those objects. And then whenever we do a request toast, we'll just do, hey, toast text equals message, okay? Now, no one is going to call this function since we haven't integrated it yet, but we can do this. If input.get key down keycode.space, we're going to do a little test, okay? We're going to send in a random message, unit-engine random.range, what kind of range we want. How about just 0 to 100? And then this is going to be a float, so we'll make it a string. Oop, random.range, sorry. Okay, we'll go ahead and make this into a string there. And there we go. So we got the first part of our system kind of mocked up. Notice we're not integrating the toast system yet, okay? We're faking a request coming into our system. We're faking an input where we're just going to have the space bar trigger a message, okay? Okay, so we're going to start flying. And I press space bar and it works, okay? We got the UI part of it working, so that's pretty good, okay? So what I want to do now is, this isn't very satisfying to me. So what I want to do is I actually want to have this toast panel actually come down in a nice juicy way. We're going to keep it up here, okay? We're going to keep it up here, and then when a message is being shown, we want to have it come down, and then we want it to go back up, all right? So what we'll do is we want to create a coroutine for that. It's a game object doing something fancy over time. So we're going to use a coroutine. IEnumerator, okay? And we want this to be somewhat generic because, maybe we want to reuse this IEnumerator to come down, but then to also go up. So let's do a coroutine let's just call it, how about this? Move game object over time, okay? And we'll do this. We want to know kind of what, we'll take a rect transform, so an RT, what do we want to move? We will take a vector 3 initial position, we'll have a vector 3 final position, and then we're going to have a float duration seconds, okay? And then we need to have it progress over time. So we need to calculate a progress variable that's going to go from 0 to 1. So let's do this. Let's go float initial time equals time.time. Okay, float progress is equal to initial time, actually no, time.time minus initial time divided by duration seconds. Okay? So this will calculate progress. On this line, it's always going to be 0, though, because time and initial time are the same. 0 divided by anything is 0. We're going to go into a loop. While progress is smaller than 1.0, we're going to keep calculating progress. This is a loop, though, so we want to yield, okay? And we're going to calculate where this rect transform should be. So we're going to go vector 3 dot lerp, unclamped. So lerp stands for linear interpolation, okay? It will give you a vector 3 between two other vector 3s, depending on a variable you give it, between 0 and 1. Here you can see it in action. Let's go initial position, final position, and then we want to have progress determine the amount we go from initial to final. This is initial time, though. Let's do initial position. Okay? Again, this function, if we give this function a 0, it will give us back a vector 3 that is initial position. If we give it a 1 right over here, then it will give us final position. If we give it a 0.5, then we'll get a vector 3 that is midway between initial and final position. So this is the perfect function to use with our progress variable, which goes from 0 to 1. Because it goes from 0 to 1, it will give us vector 3s that are progressively getting closer to final position from initial position. So we'll go RT, that anchored position equals, whenever you use a rect transform, if you want to set its position, you want to use anchored position and not normal position, okay? Unfortunately, that's another thing, that's another gotcha you have to remember when it comes to UI. So we'll yield return null to keep us from locking up. And I believe that's going to be about it. RT.anchored position equals final position at the very end, and then we're done. So this is a function that will allow us to move an object up and down, okay? However, we need another coroutine to actually process that. So let's do process request, and it takes a message. And so let's see here. What do we want to do, chat? So if we think about how our design should work. So what is unclamped versus normal lerp? So here, this is lerp unclamped. There's also lerp. So if you do lerp, then you can only provide a progress value of 0 to 1. However, with unclamped, you can provide a negative value. You can provide a value that's larger than 1. And it will actually go beyond the final position, which is going to be useful in a little bit for a cool little effect we're going to do. All right? So if you think about how a request should be processed, right? A request comes in. It's a message, okay? What we want to do is first, we want to set the toast text. We want to set the toast text to this message. Then we want to bring it in from off screen. Then we want to wait. Then we want to take it away, okay? So we need to do these things. So first, we set the message. Then, hold on. We set the message. Okay, there we go. Then we want to move the game object. Which game object? Well, we want to move this one, the toast box RT. Okay, we want to move our toast box. Where do we want to move it? I don't actually know that. Let's take a look at Unity. Where do we want our final position to be? We want to be 0, 10, 0. Okay, that is our hidden position. Let's make it a little variable up here. Vector3 hidden position. That's going to be vector3. Can I do a new? I don't think I can do a new up here. So let's do just 0 for now. We're also going to have a visible position. In the start, we're going to set this to what we want it to be. So hidden position is going to be 0. What was it again? It was 10, I think. 0. Our visible position, let's go ahead and experiment. Well, here. Our visible position should be about, let's look at it, about, how about negative 130? Okay, negative 130. So remember that. Okay, visible position is going to be negative 130. Okay, so now we know where we should go from, where we should go to, and then how long should this take? We can probably hard code it for now. Let's have this take 1 second. Okay, that's kind of probably a little bit long, but that's okay. So we set the message, and we also want to yield on this because we want to wait for it. Yield return start coroutine. Okay, so we're going to wait for this coroutine to finish. This coroutine will bring the object in from the hidden position to the visible position. We'll bring our text box in. Then we want to wait for a little while. So yield return new wait for seconds. Let's wait for like 3 seconds, okay? And then we need to make it go away. So what we'll do is we'll use the same coroutine. We'll wait on it again, but we'll reverse the visible and the hidden positions. We want to go from visible to hidden now. So it's the opposite, okay? Okay, so we've written a lot of code right now, and I feel kind of bad about it because we could be in trouble. Who knows? We might have messed something up. Let's go ahead and we'll do a start coroutine here. If anyone ever requests toast, we'll launch this coroutine with the message. Okay, so I press spacebar. Request toast starts a coroutine. This coroutine sets the text box's message. It then moves it in, waits, moves it out, and should go away, okay? So let's see if that happens. I'm not so sure myself. We'll find out. It's exciting. Oh, but it is tough to program when tired. I can feel your pain, everyone. Hang in there though. Okay, so we're gonna go in and we're gonna fly around. Okay, I'm gonna press spacebar. 3, 2, 1. Hey! All right, it's in. It's in. Is it gonna leave? It's gonna leave. Boom. Bingo. All right. Okay, watch this, though. We got a problem, though. Space, space, space. Uh-oh. Ooh. What's happening to it? It's glitching out. Look at that. That's not good. Oh, my gosh. Okay, we have a problem. Our system is vulnerable, okay? Our system explodes if the user sends in multiple requests before the first one is finished. So here's what we're going to do. We're going to not let the user send a request. Okay, we're not going to let the user send a request. We're not going to process a request if we're already processing one. Okay, so bool processing request. Okay, it's going to be equal to false. However, it's going to become true when we start processing a request. And if we are already processing a request, then we're going to go ahead and break out of this coroutine. We're not going to do anything. Okay, at the end of our coroutine, when we're done processing a request, we gotta tell our system that. So we'll say processing request false. Good. Okay. All right. So now this should block us. However, we actually also have another problem because this is kind of bad behavior. What happens if we have a system in our game, like the health system, and it needs to warn the player that we're running out of health, but another message is being shown? Our message will be crushed. Okay, so I'm pressing space a bunch. I'm pressing space a bunch, and it works. It just works, okay? It won't show us another message until the current one is gone. So our system is now safer, but unfortunately, it will drop any messages sent to it that happen while another message is being displayed. So we need a better approach, okay? What we really need is a queue. We need a queue system, a queue data structure that's going to hold messages for us so that we can process them as we have time. So let's create a queue, and it's going to be a queue of messages, of strings to process, okay? So let's call this a request queue. Okay, so a new part of our system here. And what's going to happen is when you call request toast, it's actually not going to launch anything. It's going to queue up that message, okay? And that's all it's going to do. All right, so now we need a way, we need something else that's actually going to launch this process request function and actually process a request. So what we'll do is this. In our update loop, the logic is this. If we have any requests waiting, and if we are not currently processing something, then we should start processing, okay? So let's do this. Every frame we check if we have a request. Okay, so if request count is larger than 0, we have a request. If we are not processing a request, then we should go ahead and do that, okay? So if we're not processing a request, then we should be able to execute this right here. First, we'll pop the request off, new request, or let's do this next, request to be processed equals request queue dot dequeue, okay? Then we are going to launch a coroutine, start coroutine. Oops. Start coroutine. And what do we want to process? We want to process this request that we just popped off our queue, okay? Okay, so how does that work, right? We press space, a request gets onto the queue, okay? We then say, hey, if we have something, if we're not processing anything and we have something to process, we pop it off the queue, we process it, okay? So what I'm going to do to test this is I'm going to press spacebar twice. Boom, boom, okay? Right away, twice. And the question is, will we see 2 messages or just 1, okay? If we see 2, then our system is now much stronger and gives better guarantees to the users of the system, okay? So let's see here. We'll play the game. And, okay, 1, 2. Okay, I pressed it twice. We see 1 message. Is it going to show us the second one when the first one's done? Boom, it did. Bingo. All right, excellent. It works. Okay, now, no matter when you send a message to the system, it will not get dropped. So it's a much better system now. I want to do one thing that is really quick and fun. Let's create an animation curve. Public animation curve ease. Animation curve is a very unique data type that allows us to change how a graph, essentially allows us to create a graph, okay? We're going to use this animation curve to change how our progress variable, how we process it, okay? So we're going to take that 0 to 1, right? That currently just goes very linearly from 0 to 1. And we're going to use this curve to kind of make it all bendy and strange, okay? I apologize for us going fast. You can download all this code at the end of lecture. What'll happen is we created that public variable, right? we created that public variable. If we look at our at that public variable, we will find this right here, ease, and that's an animation curve. Sorry, you can't see it in the corner there. It's right here. You click it, and we have this cool little graph editor thing. We then have some presets. That is the exact curve that we had been getting, right? It takes a variable on the x-axis, and it gives us the y. So that's kind of boring. What I want is something like this that comes in fast and then slows down at the end. Let's take a look at what this looks like. Okay, so I press space and look, it kind of comes in like that, very, very smooth. Let's do something else. Let's have it come in, go too far, but then come back in this wiggly pattern. Spacebar, oh cool, right? So it comes in and then kind of goes back. That's really nice. Let's make this a little bit faster. Duration is not going to be 1 second, but 0.25. How about that? 0.25. Cool. Okay. We'll check out how this looks real quick. Something to note, everyone, is what we've done. Like, we have the system in right now. It's working. It's functional. But however, it is currently... Oh, look. Wow, that's really fast. Look at that. Wow. Whoop, like that. Looks kind of nice. So we have the system in the game right now. However, so something is going to go wrong, I believe. Something is going to go wrong when... actually, so here's something to talk about. Right now, we're faking the inputs to the system, right? We have this this little bit of code that's like a cheat, right? I press spacebar and a message goes in. We don't want that, okay? We want this to be called by other systems in the game. So we need to make the system super accessible. We need this function to be as easy to call as possible. Now, one thing we can do is we can do static, okay? Right? If you put static in here, then suddenly a lot of really cool things happen. So where's the score function? So this is bird score. This is the function that gets called when the bird has scored. Okay, you can see score updating. So what we can do is we can go toast system dot request toast, right? And we can just put in like, you know, congrats, and then give them the new score, right? So this is pretty nice because you can actually get to it from all over the code base. You can just type that and it will just work. That does not actually work at all if you don't have static in there, okay? And the question is why? So this code no longer works. Well, the reason is if you put static into a function signature, if you put it into a variable, if you put it anywhere, what it does is it takes that variable or function and it makes it a member of the class. Okay, it makes it a member of the class instead of the instance. Okay, when you have just public void request toast, or when you have just no static at all, it's an instance variable, which means that you need to have like an instance spawned, and so what would happen is if we tried to call this function, right, toast system.request toast, we can't actually do this because C# has no idea. It has no idea what instance of the toast system class we are trying to call this function on. However, if this function has static, it is not a part of any instance. It is a part of the class itself, right? Essentially, it makes it into a public global variable. Global variables are spooky. However, they can be extremely useful. And what we're going to do is we're going to make them much more organized and safer in just a sec. So this is really nice because we can now call this function from anywhere. The API is accessible anywhere in our code base, which is great. It meets our requirements. However, it doesn't actually work. And the reason is because it can't use these variables. A static function, which is associated with the class, cannot use instance variables because, I mean, what instance, right? The class doesn't know what instance we mean when we say request queue. every toast system has a request queue. There could be many toast systems. In reality, however, we don't want there to be more than one toast system, okay? We want there to only ever be one. And this makes use of what's called the singleton pattern, okay? When you have an instance of a class, but you want to make sure that there's only ever one, all right? So what we'll do is we'll create a singleton out of this class. And here's how you do the pattern, okay? What you do is you create a variable. It's a static variable of the class type. So static toast system, and usually you call it something like instance, okay? When the game starts, this is equal to null. However, in the start function, this instance needs to claim itself as being the one and only instance ever, okay? Here's how the code goes. If instance is not equal to null and instance is not equal to us, then we need to destroy ourselves, okay? And we need to stop executing code. Otherwise, if the instance is equal to null, we say, okay, we are the instance now, and then don't destroy our game object when the scene loads, okay? This is how you implement a singleton pattern in Unity. Again, here's the logic. Whenever this whenever this component is instantiated into the scene, and this could happen when the game starts, it could happen when the game resets or loads, it says, okay, does there already exist a toast system? If it does exist, as in it's not equal to null and it's not us, then we need to go away because there can only be one toast system and we're the second one. So we destroy ourselves, we stop executing code. If this component runs, if it starts, and we notice, oh, there's no instance yet. This variable is cleared. It's nothing, right? It's null. Then we say, okay, you know what? The instance is us. We are the one and only instance in this game. And we don't destroy our game object when the scene loads, okay? So because of this, we always have one instance variable that we can always refer to. So we can now go instance.requestQueue.enqueue message, okay? And now we're back in business, all right? However, I think this might this might run into problems because actually, let's see what happens. I think we're going to get an error because I think while we don't become destroyed, I think other objects get destroyed. We'll see though. We'll see though. Always test. That is the big takeaway. Always, always make a change, a small change, and then test again to see what's going on. All right. So we're going to run our game here. Then we're going to die, and we're going to reset the scene. Okay. So, oh, sorry. I need to leave in the code that does our cheat here. Where's our code? That is the wrong project. Don't save. Okay. So in update, we need to bring our code back really quickly. Actually, wait a second. We should get a message when we score, shouldn't we? Yep. So let's just do that. Okay. Hey, there we go. All right. So we've got this coming in and going away and giving us, oh, and I'm dead. All right. Okay, so let's see if we have any errors. I think we'll probably have some errors. Ah, okay, yes. So the text is not going back to normal. And the text is destroyed. Yes, okay. So the text here, the problem is we didn't destroy the text, but the references themselves got destroyed. Okay? So what this would need to, we would need to just change this right here. Score text should be set when game control awakes, and score text is going to be, what is it going to be? It's going to be transform or dot find, actually game object dot find canvas dot transform dot find. Let's see here. What is it called? So we got game control. We're gonna grab the canvas, and we're gonna go down canvas score text. There we are. Okay. Score text, and that is a text. So we'll get component. text. Okay. Cool. So what this is going to do is it's going to refresh that variable every time we reset the scene. So every time game control loads, it makes sure and it grabs the most up-to-date version of that variable. Okay. We can do the same thing for this. Okay. Game object. Okay, so I think this will help us out. Let's see here. Yeah, the inspector refs, unfortunately, they're invalid. When the scene resets, everything gets destroyed except for our canvas. But the reference, the variables, the public variables, because we dragged in the text into the game logic component, they're gonna be invalid. They're gonna be null. So that's the problem. So let's see if we still get the error here. We might have to reset the text too. Hey, that works. That's good. So can we set the text as well to be nothing? Score text. That text equals that. Okay. Enabled or set active equals false. Let's see if this fixes it up here. I'm going to go a little bit late, and that's fine. You don't have to stick around, but you can refer back to this video for the ending if you need to bolt a little bit early, okay? It should be more than about another 10 minutes or so. Okay, so we're going. Let's get that toast to pop up. Hello? What on earth? I think I'm getting trolled here. Is the, are the things just not spawning in? That is very strange. Oh, that's why. Okay, this needs to be this. Okay, I turned off the object that spawns the pillars, right? So that's why the pillars weren't spawning. Okay, so hopefully we'll get some pillars going here. Okay, here come the first pillar. Gonna grab the point here, and then I get knocked out. Boom. Okay, the text all works. Okay, we reset, and boom. Great. The references were reset, which means the text should hopefully work just fine. Get that point, scores back, and that's back. Okay, excellent. Good. It works the way we expect. Okay, cool. So we now have the UI working, right? Remember at the beginning we created the UI, we designed the UI, and we mocked it, we faked it, right? Spacebar, the message shows up. Now, when it scores, it actually is integrated. So we're no longer using that cheat code. We can probably remove it if we still have it. It's gone. Okay, and game control now calls that function to request a toast. And you could put this in any system, right? It's not the high score part of it yet, but that's fine. It's okay for now. So one thing that you should think about is right now, this is actually spaghetti, okay? And the reason is this. The game control system, okay? The game control system, in order for it to send a message to the player, it needs to know about the existence of the toast system, okay? And ideally, we don't want that to be the case, okay? This game system, this game control system, it should care. It should not care at all about the toast system. In fact, if you removed the toast system from the game control system should be totally okay with that, right? It should still compile. It should still be fine, okay? But unfortunately, that's not the case currently because it has this hard coupling to toast. It has this line that would make no sense if toast system disappeared, okay? In other words, the game control system needs to know about toast system, and that makes no sense, right? The game system should just focus on handling like the player's score and the death state and stuff like that, okay? It should not care about the existence of a toast system or not. So here's what we're gonna do. We're gonna use the observer pattern to get past that, okay? So here's what we can do. We're going to use something called a delegate, callbacks. Has anyone in chat heard about callbacks? Callbacks are extremely nice. And what will usually happen is a system, like the game control system, will provide a set of callbacks that other systems can listen on, okay, can observe. That's why it's called observer pattern. What we'll do is this, okay? We will do public, let's create a delegate here. Public delegate, how is this? Void, so void float param, okay? And this will take a float f, all right? So what this is doing, this is going to be a little bit confusing. Yes, this is like events. We're essentially creating an event that the other systems can listen in on. I don't use Unity events. I think you can use Unity events if you want to, but I prefer to use the kind of vanilla delegates and callbacks, okay? So what we've done here is we've created a function signature. Now what we'll do is we'll go public static void float param, and we'll call this onscored callback, okay? Now this is essentially a callback, okay? This is a list of functions who are listening in and just they've registered themselves. So what happens is when we score, we increment the score and we say, hey, if there are any functions listening, right, any callbacks registered, what we'll do is we'll call them, okay? We'll execute all those callback functions and we'll give it the score, okay? Every single one will get the score, okay? So now what we can do is we can have a system that listens in on a score event and automatically sends a toast, okay? Let's create another system here. Let's call this the event manager. Or how about they call this, no, let's call this the user messaging system, okay? The user messaging system is going to be responsible for setting up messaging callbacks and sending out toasts, okay? User messaging system. We'll wait for Unity to load this up. Come on there. Let's go, let's go, let's go. Okay, great. So we've got the user messaging system, right? When the user messaging system starts, what it's going to do is it's going to try and set up a callback on the for the game control. It's going to go on scored callback, okay? We want to register a function with the on scored callback event, all right? So what we'll do is we'll create a new function that's going to be called on score occurred. Is that how you spell chord? Let's just do on score. It'll take a new score, and what it'll do is it'll ask for a toast. It'll say, hey, congratulations on the new score, right? And we'll register it. Okay, so what this has done is it has said, hey, game control system, when you score, I want you to call your callbacks. And one of those callbacks is going to be this function right here that makes toast occur, all right? So now game control is no longer coupled to the toast system. Game control doesn't need to know at all about the toast system or the user messaging system, okay? In fact, it doesn't care if either of those things don't exist. All it cares about is that the game control system allows other systems to register a function that takes a float parameter with the game control system. Whenever a score happens, it will notify all of those registered callbacks if there are any, okay? And so let's see what happens. The user messaging system is coupled to the toast system, but that makes a lot more sense than the game control having to know about the toast system, right? So let's go ahead and play the game and see what happens. So again, the magic here is that we've taken all of the toast-related code out of our central game manager. And hopefully it will still work despite that. Come on, let's go, let's go. All right, we'll wait for the pipe here. We'll go through. hey, there we go. It still works, despite the fact that we've removed all of the toast-related code from our game control. We've essentially de-spaghettified game control, okay? Again, the takeaway here is that game control system does not have to care about any other systems in the game, okay? All it does is it provides a service. It provides a callback, an event for other systems to observe. That's the observer pattern, and it helps de-spaghettify certain systems. All game control has to worry about is its own business, its own responsibilities, okay? Does not care about other systems. Now, this works, and it works pretty well. I encourage you to use something like this. However, it's not perfect, okay? For instance, despite the fact that game control is no longer coupled to user messaging system and toast, user messaging system is still coupled to the game control system because it needs to know that it exists, okay, in order to register a callback and get event updates. It gets scoring events, right? And so here's a question for you. Is there a way to decouple not only in one direction, but in both? And the answer is yes. There's a pattern called pub/sub, which is very fun to use, and it feels very elegant to use. And essentially, it allows totally different systems to receive each other's events without knowing about each other. It's really, really cool. And by essentially the way it does this is a kind of a third-party layer, right? An event bus, which takes in a bunch of events and distributes the events to people who have subscribed to them. But anyway, we'll talk about that later. We've gone a little bit over time, okay? I encourage you to look through the code here. I've posted the code, and you can download the package, the starting package, the finished package here on the agenda. Okay, you can look at the code in the course repo too. If it doesn't make much sense yet to you why observer pattern would be useful, and why it helps get rid of spaghetti, think about it this way. Game control might want, maybe we want to play a sound. We want to play a sound whenever a point is scored, okay? Whenever a score happens, we want to play a little jingle, ding, right? Now, before the observer pattern and the on-scored callback that we set up, before setting up this event, game control would have to have audio code in it, all right? It would have to have something like this, audio source, .play clip at point, and it would need to have audio related code inside of it. Now, why does your game control, like central system, why would it want to have audio code in it? And what happens is you get into a project and suddenly you notice that, wow, like this component that has nothing to do with audio suddenly has all this audio code. And maybe like I've got another component that has physics code in it, but it also has audio code, but then it has player related code, and it also has a toast messaging line in it. And suddenly you've got these components that are referencing all these other systems, and it's just kind of a mess, right? And so observer and events help you get out of that, okay? It just says, you know what? This system doesn't care, okay? It does not care about audio, doesn't care about physics. The audio system, which is dedicated to audio, can listen in for events, right? For scoring events and do the audio itself, okay? So it helps us keep all of our logic kind of in places where it should be. It keeps things well organized. Anyway, this is one technique you can use to help fight the spaghetti. We'll introduce other systems at a later date that can help you even more, okay? Anyway, I'm sorry for going a little bit over, and I'm sorry for being a little bit sleep deprived today. But I hope you got use out of this. And I'm going to throw on some music, and you can ask questions for about the next 10 minutes, okay? I'll be around until like 1:40, 1:45, all right? Get some music going. All right, go for it, chat. Cool. Any questions, chat? You can ask questions on the assignment, the homework, the projects. You can ask questions on these patterns. How's life? It's I'm very tired right now. The game that the tower defense game I showed you, I've been crunching on it, unfortunately, and it's not very fun. You think I'll get botted on the game or on this Twitch channel? I could get botted, but we're not on Twitch. Have we been botted? So I assume Ish will be banning any bots that show up. Yeah, so that shouldn't be a problem for too long. Yeah, so that is a lot of new info. However, I encourage you to digest it, right? Check out these example projects. One of the reasons we need to get this info to you as soon as possible is that the moment when it is most useful is kind of Project 1, right? So, for instance, you can implement the UI in Project 1 using the observer pattern. You can kind of de-spaghettify some of your systems using that pattern. So, anyway, I encourage you to kind of slowly go through the lecture. Please revisit this recording as many times as you need and experiment around with the code, okay? I'll be bringing these patterns back up as we go through the course when it might be useful, okay? Yeah, for now though, just focus on P1, okay? This is a really good thing to try. These patterns are really great to try for P2 when you get a fresh new code base. And it's also really good to try for your custom level as well. If you need like a centralized system to do some sort of crazy new mechanic for your P1 Gold assignment, then that might be a good use of singleton pattern, for instance. So I actually do recommend it, but you have to be careful. If you think, what I recommend is making a branch in Git if you're using that, or make just, copy paste your project directory if you're using Collaborate. And what you can do is that, I think Twitch just went crazy. Oh, I think we just got raided by someone. That's really strange. Anyway, what you can do is go back and see if the refactor is quick, okay? Because you don't have a lot of time on Project 1 for refactoring. This would be a good time to do it, though. This would be a really good time because, for instance, you may have done one enemy for P1 Gold. However, you'll need to do like P1 milestone, but you'll need to do 5 for P1 Alpha. So you want to refactor now so that those enemies scale out, and it's really natural and bug-free to create those additional enemies. So feel free to refactor. I encourage it. You'll learn a lot, but be careful because refactoring can take a lot of time. You want to maintain the possibility to go back to the old way if, for instance, your refactor fails. If you introduce some bugs or if the refactor just wasn't a good idea, okay? Yeah, that's okay, Ish. I mean, most of the lecture is basically done right now anyway. So why don't you keep asking questions, chat? If you did ask a question before the raid there, you might need to go ahead and re-ask. Yeah, I will say I like this more than Zoom, in part because there's essentially nothing anyone can do to hijack the stream. The most they can do is just spam chat, and that's not a huge deal. Yeah, you want to avoid duplication and refactoring now. If you think that's going to help, then do it, okay? And really think to the early example in the lecture, right? Whenever you add a new piece of content to the game, whether that's a new component, whether that's a new asset, think about this. how many different places in the code base, how many different places in the project do I have to go to every time I add that new thing, right? You want to make that as small as possible, right? So that you can scale out. So that, you know, adding new stuff to the game is as easy as just creating that thing and just dragging it in or creating new component and you're done, right? If you ever find yourself having to jump around the code base and hook things up, then that's a bad sign. You don't really want to be hooking things up. That can indicate that you have a scaling issue somewhere in your code. I'm gonna go ahead and let me see here. Okay. Yes, I do have tips for raycasting. So here's one of my tips. So if you're raycasting, sometimes you get confused about, okay, where am I raycasting to, right? So the raycast function, it requires a ray, right? So physics.raycast. If you look at the signature, it requires a ray, or an origin and a direction, or multiple points. What you can do to visualize where that raycast is going is you can create this function, onDrawGizmos. And what onDrawGizmos will do is you can use, I think, gizmos.drawRay? Yeah, so if you have a ray that you're using to do a raycast, and let's say it's going from, you know, vector 3.0 in the direction of you know, vector 3.right, okay? What you can do is you can just draw that ray. You can have it drawn, and hopefully we'll see it. We can also color that ray, gizmos.color, color.red, okay? So then what'll happen is, this is a unique function that executes every single frame in the scene view, not in the game view, in the scene view. This is purely for helping the developer visualize stuff. So let's see if we can find this, actually. I'm curious how long this array is going to be when we look at it. So the game's paused. Hopefully we can go into the scene view and see it. We will see. Okay, recompile, okay. I don't use Visual Studio Code, so I couldn't tell you. But I imagine if you Googled Unity Visual Studio Code, you'd find some extensions. NoviCat. Okay, so we're gonna run the game, and we're gonna see if we can spot our raycast here. Where's our raycast? Where is it? Let's see here. Can we? Where's the bird? Where's 000? I don't even know where that is. Let's see if it's being blocked by something. Bird is, so it should be on top of the bird. Where is it though? Is it being blocked by the background? Ah, there it is. I think that's it, right there. It is, there it is, there, that's it. It's right there, it's that line right there. So that line kind of stinks, I'll be honest with you. So let's do this. From 0 to 1, 0, 1, 1, okay? Yeah, so this should be going, wait, I messed that up. So hopefully we'll see the raycast going kind of at an angle. Yeah, Unity is just very slow these days. There it is. See it? See it? There's the raycast right down there. So anyway, what you do is that if you have a component that's raycasting someplace and you don't know if it's hitting something or where it's going or why it's not working, what you can do is you can use onDrawGizmos to visualize the ray that you're using. So you can then actually see in the scene view where that raycast is going and if it should be hitting something. Another tip, though, is if you look inside physics.raycast, there is actually some signatures that take a layer mask. Okay, a layer mask that will decide what the raycast can hit and what it cannot. Okay, now a layer mask is actually a cool little data type. Public layer mask, test layer mask. What you can do is you can make a public variable of layer mask, and it will let you basically customize what you want to hit. Okay. So if you want your raycast to go through certain things but hit other things, then you can do that. Let's go to game control. Where is it? I miss it. There we go. And there it is, right there. Test layer mask. So you can say, hey, I want to hit everything. I want to hit only players with my raycast. I want to hit enemies and all that stuff. Okay? Yeah, no problem. Okay, so let me go ahead and post this to the... Go ahead and post this right here to the schedule. Gonna make it small like the rest of them. And then what I want to do is I want to save the rest of this. I want to save the rest of this for for lecture 5 on Wednesday. Okay. Cool, okay. Okay, hey chat, any other questions? We'll give you another 3 minutes, chat, and then I'm gonna peace out. Ah. All right. Okay. I'm gonna head out. All right, chat. I wish you the best of luck on your P1 Alpha. Have a fantastic day, and I will see you Wednesday, okay? Bye-bye.